And we're live. Thank you very much for your time. Good morning, everyone. Welcome to Build, and welcome to one of the two open source sessions we have prepared for you here in the Azure breakout sessions. My name is Jose Miguel Parrella. I'm an open source product manager with the Microsoft Azure team. I'm joined by a number of my colleagues that I'll introduce in just a few minutes. And we're really excited to share with you all this open source goodness in the cloud and how we're approaching open source in this particular point in time. There's no shortage of announcements and cool things to share. And sometimes it's hard to keep track of what Microsoft loves anymore. But there's a lot of love in the air. And today we want to share a little bit of that with you. In the cloud, wherever we look, there is open source driven innovation, where you're looking at next generation architectures driven by containers, where Docker is a very important piece of technology, all the way up to DevOps and IoT. Open source really is eating the cloud. And that is something that we've embraced at Azure for a number of years. While we also understand that Microsoft has been on an open source journey for quite a while. If you look back, it's been more than 10 years of open source goodness, releasing and contributing to many different open source projects, and from the older things, if you remember Codeplex, to the newer things, .NET Core, for example, and things we've continued announcing. So we've been in this journey for quite a while, and one of the interesting things is how do we balance between embracing, enabling, integrating, and contributing first-party open source solutions like .NET Core and third-party open source solutions as well, like Linux. And that is exactly what defines our approach to open source in the cloud. We'll look at it from 4 different points of view. Enabling open source, so customers can bring whatever they want to use, whatever they love, and whatever their investments are today to the cloud. Hadoop is a great example of that. Linux is a great example of that as well. It's not just about that. There's a lot happening in that space, but it's about integrating open source into our first-party solutions as well. If you think, HD Insight on Linux, what you're looking at is Hadoop distribution running on top of Ubuntu. If you think of Azure Container Service now in preview, what you're looking at is Docker, technologies from partners like Mesosphere, and running on top of a Linux distribution like Ubuntu. Think Redis Cache, think Azure Search. You're going to see more and more of those open source integrations into our first-party solutions. And obviously, releasing and contributing will continue to happen. There's a lot happening in the developer platform, visualstudio.net, of course, and also in Azure. And David's going to share a little bit more, what we're doing in the SDK and API space. But even the little things, Azure content, for example, most of the things we post in Azure.com as technical documentation are also on GitHub repositories. Now, this approach to open source innovation in the cloud has yielded some really cool results. If you look at Azure as a platform where we offer many of these solutions, there's a lot of logos, too many logos. A lot of partner solutions, a lot of third-party solutions from the ground up, from the infrastructure all the way up to management, monitoring, DevOps, et cetera. What we wanted to do today is translate this into what really matters for you as a developer from an application platform and from a data platform standpoint. We actually have 2 sessions, one before lunch, this one, and one after lunch at, I think, 2 p.m. We're going to talk a little bit more about data platform as well. And we want to abstract the fabric, the concept of the fabric, the virtual machine, the container, running on top of Linux, running with Docker, et cetera, and talk about what Azure can really bring to life for you. Now, 2 things I wanted to say before we get started with the content. We try and make this really easy for developers to consume. One way we do this is through stacks. And so in Azure Marketplace, you can find today a large number of open source stacks, whether you're looking for a finished application like a CMS or a tool like Track, Redmine, Jasper, et cetera, or just a stack like the lab stack, the mean stack, and you just want to develop on top of that. We have those things in place today. We have renewed our partnership with Bitnami to offer certified Linux-based images in Marketplace, and we have over 120 of those Marketplace available today. In fact, if you look at the entire breadth of offerings in Marketplace, 60% of those are Linux-based. So if you have ever heard that 1 in 4 VMs in Azure run Linux, which is an actual fact, 60% of Marketplace actually runs on Linux-based images as well. So if you're clicking around on many of these Marketplace solutions, there's a 6 in 10 chance that you'll continue increasing that number 1 in 4 to something bigger. The other thing we do to make this easy is embracing the tools that you are using today as part of your DevOps thinking. So, it doesn't matter where you are in your DevOps journey, whether you are just enabling tools for development or also for building, testing, deploying, as well as monitoring. Open source has a real relevance and really drives innovation in this aspect as well. And we support Azure through many of these tools. We're going to discuss a little bit more about where are we in the adoption of new things like Azure Resource Manager and how this open SDKs and APIs really enable these third-party tools as well. With that, I'd like to welcome Boris to stage. Boris is a program manager with the Azure team, one of the many people working with Linux and open source at Microsoft. So just switch over to your
All right, I'll continue with slides, and then actually we'll do the demo after that.
Thank you.
Good morning, everybody. Thank you for coming again, and thank you, Jose, for the introduction. So my name is Boris Bereshnikov. I'm a program manager in the Azure Compute team, working with a number of the open source technologies. So what I would like you to show and talk about on the slides before we actually jump in a couple of actual demos is a few scenarios that we are considering, and we're going to be focusing on only one of them in terms of the demos. So for your different workloads that you can bring to Azure, you can look at those three different categories of things. So you can effectively run on the virtual machines on the set of technologies that the platform provides itself. So this is a section of the horizontal scalability for Linux backends, and we're going to look at that a little closer through the demos. As well as you can use existing technologies, the technologies that are other than the VMs themselves, such as the web apps or any kind of dev services. And I think that one of the key messages we want to relate today as far as those two session presentation is the fact that you can actually use a lot of open source technologies together with the native platform, in this case being Microsoft Azure native technologies combined, kind of getting much better value out of the application, getting to any kind of innovation that might be happening in open source, and you can employ that innovation in developing your own applications much faster. And finally, the last category of the scenarios is the container-based scenarios. So again, something that we have as dedicated sessions through the build. So one thing that I would like to mention here is that we have Azure Container Service now in public preview. This is the set of technologies that Azure provides for you to help build the containerized application directly on the Azure platform without having to manage individual components of that system. So with that, a brief introduction in terms of what set of things the platform itself provides in terms of the control, in terms of the features you can implement, and what you're actually gaining depending on which technology you're picking to deploy your application to. So on the left-hand side, you have a traditional infrastructure as a service, things such as the VMs, so individual VMs where you actually create a VM and provision software in that VM, going all the way up through kind of extending those VM images through VM extensions using containers directly running on those VMs. So you still deploy those, or you use third-party frameworks to work with them. Then going into a new set of features such as the VM scale sets. Again, there's a separate session for VM scale sets, which is the ability for you to create a large number of the identical VMs, which helps you scale your application up and down depending on the load that happens on that application. And finally, going all the way to what's called platform as a service on IaaS VMs or container services. And one of them is the Azure Container Service, which is in the public preview. So as you can see on this spectrum, you're going all the way from the infrastructure as a service, individual VMs, to all the way to the platform as a service. And in terms of the control, you have a lot more control for the VMs itself. You can completely do whatever you want with each individual VM. And you're relinquishing some of that control in favor of speed of deployment, scalability, and integration of the platform when it helps manage your application and scale it up and down. And you can use a lot of frameworks, a lot of open source frameworks to actually integrate in with those technologies that Microsoft Azure provides itself. One other point I'd like to emphasize in here, so a lot of those technologies, VM scale sets and Azure Container Services, they are built with Linux in mind as being a first party. So you can deploy and use Linux and open source technology on those Azure provided services directly from the day one. So that's one of the interesting points in there. So in terms of bringing your own, kind of focusing on the left-hand side of that picture of the infrastructure as a service. So what you have, Azure by itself is the big repository. It's a platform where you can deploy your own images. And that's the logo slide that Jose showed at the beginning. So you can get your images from the multiple places. You can get them from the marketplace, which is a solution, a third-party provided solution and available in the marketplace. We have over 3,000 of those solutions. You can be bringing your own, so you can be building custom VHD of whatever the either Linux or Windows operating system and whatever software you want to put on that VHD and then deploy that to Azure. And finally, you can use Docker Registry or Docker Hub integration to pull containerized apps that might be available and might be kind of helpful for you to build your application faster. And we have a separate specific container applications that are available on the portal today that help you build and explore and start learning those technologies right away. So some examples you see in the slide is the WordPress, Drupal, MongoDB, and MySQL databases. So in terms of how you can use Azure VMs for your own workloads and what you can do from the dev and test standpoint of view. So as you're aware, as I just mentioned on the prior slide, you can bring your own images. You can kind of scale the VMs up and down. So we have a variety of sizes, a variety of things you can do. You can deploy to any of the region available in your subscription. So currently we have 24 public regions in the Microsoft Azure. And then you can scale those. You can use the set of technologies that list on the slide. So you can interact through the Azure portal. You can interact through the Azure command line tool or the Azure Resource Manager APIs. And those are the few things that we're going to be showing in the demos later on. So one of the things I've been working on through the last year is working with one of our partners is Red Hat. So in November of the last year, we announced the partnership that Microsoft Azure now supports Red Hat Enterprise Linux as a certified VM image in the platform. And one of the things we've been doing, and we actually have completed in terms of integration, in February, we announced the gallery images. So instead of bringing your own, which you were able to do since November of the last year, you can actually go and find the image in the gallery in the provisioned Red Hat Enterprise Linux VM. So this is so-called premium image, and that premium image actually brings additional benefits to you in terms of what it provides to you. And that's the integration with the Red Hat customer portal that you can see on the animated GIF in there. So with that, let me actually do this demo live and show you what it looks like on the VM. So when I go to the portal, and let me make it a little bigger. So this is a standard Azure portal UI. You go click new in here, and if you, let's say, start typing Red Hat in the search, you'll see that Red Hat Enterprise Linux 7.2 and 6.7 are going to show up in the list. And if I click and follow the normal standard provisioning procedure of the VM, again, I can pick Resource Manager or Classic VM. The point is, so this makes it really, really easy for you to bring, in this particular case, Red Hat Enterprise Linux VM running in Azure without having to prepare that image yourself, which you had to do prior to release of those images. Now, the other interesting part, the other benefit you get from this, so those are so-called premium images, so you're paying extra for having that image running in Azure. So I have one of those deployed, one of those VMs deployed, and I'm going to pick that VM in the list in the UI. So what you see, the interesting point you can notice there for the Red Hat Enterprise Linux, it has an additional line in here. And that additional line in here is called Red Hat Customer Portal. So clicking on this opens another blade in the portal that allows me to go to Red Hat Customer Portal. Now, if you can see that I'm still in the Microsoft Azure portal, and if I click on this link, what happens is the integration that we work together with Red Hat to actually make this available to you. So through the single sign-on process using your credentials in the Microsoft Azure, so effectively your Azure Active Directory credentials, I actually landed on the Red Hat customer portal side. You can see it's accessredhat.com. In my account, my Azure identity account got linked with the account on the Red Hat side. So what do I get from that? So I'm effectively accessing protected resources, the resources you normally pay for to access documentation. And for example, I can file a support case with Red Hat directly regarding this VM. Again, this is what the integration, this is what this premium image provides to you. This is an example of integration with another company, probably something that we wouldn't have thought of just a few years ago. So that's example number one. Now, the second set of things I have is actually to go and talk about the application platform as a service. Let's see, am I picking the correct machine? Okay, so the other Red Hat product that I would like to demo is the Red Hat OpenShift. So Red Hat OpenShift is the application platform as a service from Red Hat. And the thing I want to demo next is actually show how easy it is to run and deploy applications on Red Hat OpenShift. So what I have done for this particular demo is actually using, again, one of the technologies we have in Azure. We do have in Azure, the Azure Resource Manager templates. So one of the templates is coming for the Red Hat OpenShift. So I deployed a cluster that consists of a couple of nodes in the master node that I'm going to be logging into. Again, this is running in Azure. And what I'm going to do next, I'm going to go to the URL that represents the console of that OpenShift cluster. And you can see that I have a number of projects in here available to me. So what I'm talking to, right now I'm interacting with Red Hat OpenShift that runs on top of the Azure VMs. Again, I can use a variety of technologies, and we're going to be using VM scale sets to actually deploy this where the worker nodes are going to be deployed from Red Hat OpenShift. But let's take a look at what it takes to provision an application in the OpenShift. So I'm going to hit a new project, and I'm going to give it a name, build demo 2. And let's say demo for, let's say new demo, or maybe call it live demo. So what this does, that creates the, again, let me make it a little bigger. It creates the application on the Red Hat OpenShift, and I'm going to deploy the simplest PHP application in this case. I'm going to pick the latest version of available applications, and let's say call it PHP. And what I'm going to do in here, I'm going to point it to my GitHub repo where I have the application deployed itself. So I have this simple PHP file in my repository. And what I'm going to do with the, so this is a simple web page that tries to read a database and tries to display who actually visited this database, who visited this page. And from that, I'm going to point to that repository right there on the demo. Let's see. And I'm going to give it some name that is easier to remember. Let's name it build 3 OpenShift 3, and just give my vanity URL to the rest. I think everything else we're going to keep. And we're going to start with one replica, as you can see in the UI here. So I'm going to hit create. What happened just right now, so the OpenShift actually knowing that I pointed to the GitHub repo, it's going to go and pull that source of that application, going to build the image, going to deploy it on the container of the OpenShift that runs on the Azure VMs, and going to deploy that application. So one thing I'm going to do for later is I'm going to grab the so-called webhook URL so that we can continue that demo at the end. I'll explain why I need that later. So what I can do in here, I can interact through the command line, through the OpenShift command line tools. So that would be using something like OpenShift login. Again, let me make it a little bigger so that you can see on the screen better. So it allows me to log in. So I need to go grab a token from my endpoint. So this is similar to what you do with the two-factor authentication on the Azure CLI today. So I'm going to grab the command line to log in with. And I'm just going to rerun that command in my terminal window. All right, so I rerun the command. You can see that my applications are now showing in there. And I'm going to pick the demo build 2 is the one that we're actually working on. So if I type OC status, this will show me what I actually have deployed. So you can see in here is that, actually need to grab another one, OC project, making sure that I have a correct one. Yes, build demo 2. And type the status. So you can see that I have deployed application that might be live right now. So instead, I'm going to go to the UI and click on the view. So I can see I'm running on the single pod, single container. And I have that application already deployed. So here we go. So we pulled the application of the GitHub. We compiled it, and it actually got deployed right on the OpenShift platform. We can look at the builds. But then let's say this application has no state knowledge, right? So it did say that there's no database attached to it. So let me show you how easy it is to attach a database to this particular application. So what I'm going to do, I'm going to go and say I'm going to add to the project MySQL database, and I'm going to pick ephemeral in this particular case because I don't want to say state for the demo. I'm going to pick the username and password in the way that I don't have to type the command lines. And I'm going to hit create. So creating this will put another container and put another service on the OpenShift application, and I'm going to have those two together. Now, what's going to happen, you can see in here, if I'm going to go to the overview, clicking again, you see now I have two services. So I have my PHP app and my SQL app. Now, going and just refreshing the web page, you will see that nothing changed. And the reason is because the PHP application has no idea about the database application. So what I'm going to do, I'm going to define the variables, the environment variables for the applications. So I'm just going to type OC status. And I'm going to look at what my service is listening to in terms of the service container. So I'm going to grab its IP and use the command line I created before. So what this does, it actually lets me create the environment variables, what you see in here. So I'm defining the environment variables for the PHP applications. I'm pointing to the particular host it listens to, port and username and password that I was typing in the form UI. So once I hit enter, what this should do, this updated the PHP application. And this now, the PHP application technically should know what exactly it's supposed to do. Let me verify that I'm in the right place and I'm on the right application. All right, so build 3. Let me see OC project. Oops, wrong command. Status. Right, so I am in the demo. In the live demo, build demo 2, right? All right, so you can see here I just hooked up the database, and now if I start refreshing the page, I will start seeing the demo. Now, one thing I'm going to actually skip a little bit on. So the thing you can do in here is that I can scale that application. Let's say I can, let's say if there's a lot of load, I'm going to scale it to 4 pods. And you can see in here is that the new containers are getting created as I'm deploying this application, and they're becoming active. Now, if I keep refreshing this page, what you will see is that at some point, as those containers are coming live, I will start seeing more IP addresses showing up on this list. I might have to open another browser session to see this, but that sort of illustrates how easy it is to deploy the application and what I was able to do. One other step I want to demo before we finish with that particular demo is the continuous integration. So this is the web page I opened in the Visual Studio Code, and as you remember, the web page itself just shows the hello build and visitor database. So I'm going to change that page in here and add the continuous integration line in action. I'm going to save that because I'm on the Visual Studio Code and I'm hooked up to the GitHub. I'm going to make that change, and I'm going to submit the change. So let's say trigger build, and I'm going to submit it. So what I have done, I have submitted to my local repo. You can see that I make it a little bigger again. So I have made a change to the local repo, and I'm going to push that change to the GitHub. So once I push that change to GitHub, so see what happens on the application itself. So we're going to go back to the portal, and you can see that in the overview, you can see that the image build for that for the application I put a webhook for. The build has started, and that build will actually start deploying the application directly on the portal. So once that deployment completes, we will see that the new application is actually available, and the pods are replaced with the new content on the site itself. So that's sort of the brief introduction of what the OpenShift looks like on Azure. Again, we're running this on Azure. We're running this. Kind of, you saw how easy it is to hook up the GitHub repository, make changes, and scale the application up and down, and see what things you can do on Azure in terms of open source and various technologies available to you. So let me switch back to my slides. All right. So one other thing that you might be interested in is that it has been announced relatively recently. So the .NET so .NET OpenShift is intended to provide .NET runtime distributed with the OpenShift itself. So what you have seen in the demo itself, we have a number of containers, number of solutions available to me. So I was able to pick PHP, and I was able to pick MySQL that were available as a part of the initial install. So if you want to explore this further, so the .NET Core will start with 1.0, and then will be revved roughly about every couple of months. And if you want to start exploring this, you can go and take a look at the docs.openshift.com and pick the version, either open source version or the Red Hat Enterprise version from the site at the beginning, and just follow the installation on top of the Azure VMs, and that would be a relatively easy process to do. Now, one thing that we're doing in the coming weeks is actually to provide a template, which simplifies a lot of the sort of these minor details you need to type in the config files and make them available for you. All right, so with that, I think I'm going to pass this to David. So we have, again, one of the other things that I'm going to mention is, so VM scale sets, one of the technologies I very, very briefly touched on is dedicated session will be tomorrow at 3:30 by Guy and Kundana. And I think with that, I think I'm going to transfer it back to you.
Thank you very much, Boris. I think it's a very cool example of leveraging that Azure Fabric, Linux-based Azure Fabric for particular use cases. We have more of those use cases. I'm actually going to share towards the end of the session a GitHub Pages site where you can see some of these use cases in terms of an architectural blueprint. But it's about dev tests, just-in-time fabric, backends. We see a lot of data as well, and that's just our visual cue to remind ourselves to. There's 1 in 4 VMs running in Linux today, and obviously we want you to continue exploring Linux Fabric for your application platform and data platform needs, and to increase that number because that's very cool. So it's not just about leveraging the third-party solutions like OpenShift Enterprise that can help us enable that application platform. It's also about the developers themselves. We recently launched a new Java Developer Center. For those of you working with Java, we have a new web experience for that. And we have a new landing page on our GitHub organization, so azure.github.io. We really appreciate that you are spending the time learning more about open source and integrating more of the work that you're doing with Microsoft Azure. And these are 2 great resources to get started. I actually wanted David to come up on stage and talk a little bit more about that. David is a program manager with the Microsoft Azure team focusing on developer experiences, and he's actually one of the champions of open APIs and SDKs for Microsoft.
Thank you, Jose.
Thank you.
It's great to be up here, and I'm super excited to be here. Thank you. Again, I'm David Justice, and I'm PM in Developer Experience in Azure. And I'm a big fan of DevOps and APIs. So today, I'm going to talk a little bit about that. It's going to have a little bit of a hashy flavor. And let's get started. So Azure APIs and management APIs in general are fundamental parts of Azure. It's like your first principles. We use them for everything that goes on top. All of that great tooling that you see Boris showing, all of these wonderful tools that we have provisioned, all these open source tools, they are all driven from the APIs. That's where everything starts. So what is important about our APIs? One thing that's really clearly awesome is that our APIs are open source from the API boundary all the way out to the SDKs, all the source code. The entire process is open source. And the specification format for the APIs themselves are actually a Linux Foundation project. They're based in Open API spec. That allows us to do some really cool things, and you'll see those really cool API-specific things in the second episode in the afternoon session. In this one, we're going to concentrate on DevOps and kind of empowering the DevOps story through our SDKs. So let's go through, and I'm going to demo Vagrant. Anybody in here use Vagrant? Yeah, woo, all right, cool. So we actually took Vagrant, so we had a Vagrant Azure plugin, and that Vagrant Azure plugin targeted ASM, our Azure Service Management APIs. Those are kind of our older APIs, and we moved it over to now target Azure Resource Manager. So let me show you a demo of this running, and I'll explain exactly what it's doing, and let's see here. Okay, cool. So deployment kind of takes a little while, and because of that, I just recorded this. So I'm going to walk through it, and I will talk through exactly what's going on as I'm doing it. So there we are in the portal. And I have the azure.github.io website. It's actually a Jekyll-based site. It's all out in GitHub. You can go and make some corrections or some additions. And I have a Vagrant file that I'm going to use to build it on Linux. The Vagrant file is very minimal. Basically just says my subscription, and I give it a tenant ID, client secret. Then I can basically just say vagrant up, provider Azure. You're going to see the information about what is being provisioned. We default to a standard D1. We put it into its own resource group with a vagrant virtual network. And then you have a network security group associated to it. And right here, what we're seeing is that resource group being provisioned in the portal while this thing is still running. So we're building out infrastructure in the portal so that we can use it to do our dev test iterations. So as we're building code locally, we probably want to actually run that in something that simulates closer to our production environment. And that's actually what we're doing right here. So as this ends up converging to a full deployment here, we'll see that the box comes up running with the fun name of Ancient Paper. It's just it kind of just gives some guesses to names, and hopefully they don't too much. They aren't offensive. So then it brings up SSH. We're actually deploying out a Linux VM here. Then what's going to happen is we're going to rsync the files between our local and that remote Linux VM. And this whole time, this is all based on our Ruby SDKs. So we've built those SDKs off of Swagger documents that get generated into the SDKs. So we take open API specifications, we run them through a code generator, produce Ruby, Python, Go, Java, C#, all of these different languages with parity across Azure Resource Manager. Now that's something you didn't see before and something that is really powered by open source. Without that open source stack, we would not have a lot of the niceties that I will show in our second session. So we're just going through here showing halting, starting, all of those normal things that you would do with your Vagrant VMs, but now in Azure Resource Manager. Finally, we'll go through and terminate, and what that does is that's going to wipe out the resource group that it created. And then all of your resources are cleaned up. You don't have resources left in the cloud, and you aren't getting charged for them. So that is Vagrant targeting Azure Resource Manager. And the preview's out there. I hope you all take a look at it, and I hope you enjoy it. With that, I think, yeah, that's pretty much it for this one. So let's see. Do we have any other slides to go through here? Thank you. OK. So now I think I have the pleasure of introducing Berzin Patel, VP of Product of HashiCorp. Thank you, Berzin, for joining us, and so glad to have you here.
Thank you. That's a hard act to follow, David. So as David introduced, I'm Berzin Patel, VP of Products. Really excited to be here. Perfect timing. We just, as David alluded to, we just recently announced, just last week, announced Azure ARM support for our entire tool chain. And in the next 10 minutes, I'm going to talk about what that entails and also kind of go through a quick demo with that. So before we get started, just a couple of words about HashiCorp. HashiCorp, at HashiCorp, we can build application delivery tools. We're a startup out of San Francisco, not far from here, just a couple of blocks from here. Been around for 3 years now, and we're often kind of better known for our open source projects. Then the HashiCorp brand itself. So David already spoke about Vagrant. There's Packer, Terraform, Nomad, Consul, Vault, Auto, Surf. All those are HashiCorp products. Could we do a show of hands of how many of you have heard of one or more of those products? Yeah, that's what we usually find. It's kind of we've got kind of a lot of kind of great adoption in the open source community, and kind of excited to be out here. We also going to have what we call commercial offerings, which are commercial products, which are enterprise offerings built on top of the open source products. We'll see a couple of those, but they're essentially kind of enterprise. They include enterprise features as well as commercial grade support. So, before I kind of get started about talking about the products, I said we build application delivery tools. So let's kind of see what that really kind of entails via this slide. So this slide should not be new to kind of any of you guys. This is age-old application lifecycle. Previously, it was called build and release. Now it's DevOps. But essentially, kind of building an application involves kind of going through these stages in some shape or form, right? So you start by developing your application. You're writing your application, and David did a good job kind of with that demo with Vagrant. Once you're kind of done developing it, you kind of package it up into an artifact, an image, VHD, whatever you call it. Then you have to kind of deploy it out, right? Kind of one instance or multiple instance, scaled up, auto-scale, however you kind of do it. In a microservices, DevOpsy world, you're going to also have this additional task of scheduling it, which is like, how do I kind of optimally schedule my applications and services on my underlying infrastructure? So that's the scheduling step. And of course, for all kind of good operations, you've got to monitor and kind of do effective service discovery. So this is really kind of the application life cycle. And what we offer are tools for each of these stages, right? So Vagrant, we already saw in detail, so I'm not going to kind of belabor that anymore. Packer is our tool to package applications, right? We'll see it in the demo, but basically you kind of start with a base image. You kind of you install what it is you have to install, either through a shell provider or kind of a call out to another config management tool, and you kind of build an image. Terraform is the tool through which you can kind of deploy out to Azure at scale. So that's Packer and Terraform are the ones which kind of recently we announced ARM support for. Nomad is our scheduler, and Consul is our service discovery monitoring agent. Now, this is application lifecycle. Everything kind of looks great, right? One of the challenges in this kind of this modern world with the cloud, with DevOps, with microservices, is that you have the problem of secret sprawl, right? You've got your Azure credentials. You may have some, in Boris's demo, we kind of saw there was some OpenShift credentials. You want a secure way to kind of store that, and that's like fundamental and should be kind of the cornerstone of everything you kind of build and design and think about. And we achieve that through a product called Vault, which is the one you see at the bottom out there, the black triangle, and basically a secure KV store which integrates with the other tools in a scalable way. Now, as I kind of mentioned, those were all kind of the open source projects. You can kind of go to GitHub and download them, use them. There are times when enterprises want enterprise-y kind of features. An example of that would be Consul with fine-grained alerting, or Vault with either HSM support or searching through the audit log. Those features are kind of offered as commercial products with the enterprise offerings. And of course, it comes with support as well. So this whole tool chain is now fully supported on Azure. We always kind of supported ASM, the Service Manager API. We kind of recently announced support for ARM just last week. So the entire tool chain is kind of now operational and kind of targeted and working on the Azure platform. It's Azure kind of, given the API compatibility, we also kind of support Microsoft Azure Stack. So that's one thing about our kind of tool chain, is it's cross-platform as well as you can support bare metal with it. You can support your cloud, as well as kind of newer stuff like Azure Stack. So it's cross-cloud and cross-platform. So let's see a real quick demo out here. Similar to kind of David, the demo kind of entails kind of spinning up Azure resources, which takes some time. So I kind of didn't want to do it live. I've recorded it. You'll see all the steps of the demo, but the pauses, the times when you have to kind of wait for a resource to spin up or spin down, I've kind of conveniently fast-forwarded through, just so that we kind of don't spend 15 minutes looking at those tasks. The one thing I want to kind of mention is I'm going to let's kind of get going. So I'll start with kind of demoing Packer, right? Just a very simple Packer run, which is taking a canonical Ubuntu Server 14.4 image and packaging it up into a VHD. So the script starts with reaching out, accessing the Azure Gallery for the server image. It pulls it down, and that's the builder. That's the ARM, the Azure ARM builder we kind of built and released last week. So it kind of pulls down the image, and then it kind of invokes a provisioner, right? A provisioning step could be, like in this example, I'm kind of using a shell provisioner, through which I kind of, for sample, we're kind of just changing some permissions and kind of creating a directory out there, nothing too kind of fancy. But it just does that and kind of builds an image for you, a VHD, and kind of puts it in Azure Blob Store. Now, the next step, which is starting up out there, is Terraform. Terraform is going to take that image, which we just kind of created, and through the command line, deploy it out to Azure infrastructure. Out here, it's just going to do one instance on an A0 just for demo purposes, but you could basically deploy out to multiple instances. You could deploy out to kind of multiple clouds as well, Azure Stack on-prem as well as public cloud. So again, nothing too kind of fancy. It just basically, the concept is that you use Terraform as the programming language to kind of build out and kind of grow out your infrastructure. Both Packer and Terraform use a JSON-like programming language. These scripts, which I kind of just demoed out here, they're in the notes section of the presentation. If you want to kind of download those and kind of run it on your own, most welcome to do that. And as you see on the screen, after the Terraform build, it's saying that 7 resources were added, right? It's this virtual machine, which I've kind of created with the associated storage and the virtual network. 7 resources were added, and you can kind of run a Terraform state to see the state of those resources. Now, if you wanted to scale this up and say you want to kind of build out 5 more instances, you could kind of just change a variable and go ahead and do that. You do not have to kind of, for the existing VMs which were already created, you don't have to kind of destroy them and recreate them. And so that kind of really helps kind of scale up and scale down. And this demo is kind of command line based, not very glitzy. There is kind of the enterprise, the enterprise offering, which does have a UI experience. But I didn't want to kind of demo that. The point I want to kind of make out here is everything we kind of do, one of the core tenets and philosophies of HashiCorp is infrastructure as code, right? We want to we want to kind of lead the way to a world where you treat your infrastructure just like you treat your code. We've got GitHub integration, and so to basically kind of kick off your CI/CD pipeline flow out there. That's how we basically do infrastructure as code, codify your knowledge, and just immutable infrastructure. So this is kind of our kind of core philosophy. This is kind of the future. This is the way of the world. And it's kind of easier and kind of more secure, safer to manage your infrastructure this way than kind of just click around and kind of possibly get a different result or an unexpected result. So we're already kind of pretty popular with our tool set, the open source tools. For those of you who kind of follow RedMonk, those are kind of some of the growth, the star rating growths we've been seeing in our projects. And wow, one more bragging slide. I'm going too fast, but OK, just some of our kind of larger customers. We measure 1.5 million active users every month across all our products. So super popular tool set, but these just kind of being some of the larger tools here. So
thank you very much. Really cool. Thank you again, Wilson. Thanks. I think this is a great example of an experience that could not have been made available if not through an open API and an open approach to who we're looking at Azure Resource Manager. We do have a landing page on HashiCorp side. You can search for HashiCorp Azure or just browse the HashiCorp side where you can get started with Packer and Terraform, and you can sign up for updates from HashiCorp as well. There are a couple of resources that we wanted to share with you today. We have an open source hub in azure.com. Sorry, just go to azure.com/open source. I already mentioned the GitHub organization that we have for Azure and the resources available for you there. And we have a Twitter account, Open at Microsoft, where we tweet all things open source. We hope that's a resource that allows you to also stay up to date with everything that's happening with open source at Microsoft. We have a session after lunch in this same room. We're going to talk about data platform. We have Ben from DataStax, another of our partners, and Boris is also, and David are going to walk us through a little bit of the experience when it comes to data platform in the open source world in Azure. We wanted to open up for any questions. If you are asking a question, just feel free to use the mic. Yeah, I think all the mics should be on.
If anyone wants a sticker before leaving, you can kind of pick up the swag.
I have a question here.
Not yet. Yeah, but it's a request we've kind of heard. So HSM is coming. The Azure part is it's on the roadmap.
The question was on HashiCorp Vault.
Yes. Sorry, I should repeat
that. Don't worry.
Yep.
I have a question. When you showed the Red Hat Premium, and what was integrated within the ARM was the link to the Red Hat site.
Red Hat OpenShift or going to Red Hat website.
Yeah. Was it like a single sign-on? Did you already have a cookie in your browser? How did it work?
Sure. So what I showed at the very beginning, going into Red Hat Customer Portal, is the single sign-on. So the first step, actually, the thing that you have not seen, so you immediately saw me clicking on the link and getting into Red Hat Customer Portal. The very, very first time you click on this, you will be prompted to link your your Microsoft identity to Red Hat identity.
Oh, I see.
And after that, is a single sign-on flow. So you never have to type Red Hat credentials to get into there.
Is that part of the API, or that was a custom?
So one of the messages, actually, as I was sitting here, is thinking about this. So this is OpenAuth, or in this case, it's SAML request going to identity provider from Red Hat application to.
And the resource manager supports kind of passing these parameters.
Right. So and again, those are the standard APIs. Those are the industry standard APIs. So that's why we're able to basically join such disparate companies from prior worlds together, and it just works, right? Yeah. So that's the thing. So the other thing, I'm going to make a correction. So the OpenShift, the one I demoed, it uses Azure AD for that same reason, because it uses the same set of APIs. It's just the identity provider. So I'm logging in with my Microsoft credentials, and I'm using cluster deployed on Azure. So there's no need to create any or manage any other identity. So there's the beauties of the APIs and the beauty of the fact that we're supporting Linux workloads, open source workloads as a first party. So those things just work. Thank you. Any other questions? We can see people coming to microphones. All right, go ahead.
So comparison of Vault and Key Vault. Perhaps feature comparison?
Yeah. That's a longer discussion, but kind of happy to take that offline with you.
All right, go ahead.
So with the OpenShift, there's no template on the marketplace as yet to actually spin up an OpenShift environment in Azure, is there?
So the question is there anything on OpenShift to spin up OpenShift environment in Azure? As of right now, there's a private repo that we're working on a quick start template to actually put into GitHub/Azure quick start templates to have it available. Right now, you just go to docs.openshift.com, pick, if you have a paid version, pick enterprise, right? So I guess what you're demoing, do you want to demo that or?
Yeah, sorry. I was trying to. There you go. That's
so this is the quick start template that does this job of provisioning individual pieces and deploying the VMs and configuring all the settings. This is somewhat elaborate template, and there's still work to be done to actually make sure this is error-free and things like that. So that's why we're not advertising this yet. But once that pull request is integrated into quick start templates, you'll be able to just do the standard OpenShift, click deploy, and that should work.
And the last one I have is about the orchestration engines going out on Azure, like Resource, Swarm, Kubernetes.
Nomad.
So the question is, orchestration engines, Swarm, Kubernetes, I don't know, Mesos, does this come up? Or so in this particular case, so what we're trying to do as a strategy, we're trying to make sure those things work with Azure. So in, let's say, in Azure Container Service, we're using Mesos-based APIs or Swarm APIs or Docker Machine. There's some updates we have made recently. So you can use all of those things in Azure, and as long as they're industry sort of default standard APIs, we will make sure that they work on Azure. So that's our goal. I guess as with anything, when there's like lots of technologies coming together, one of them will probably dominate after some time. But from our point of view, we want you as a developer, as the person who may be familiar with one set of things, come to us and work with us because we support that technology running on Azure.
Yeah. Add Nomad to that answer, and Nomad does run on Azure. Yep.
Any other questions?
Yeah, I have a question about Packer. I was wondering when the Hyper-V support would be added. If that's in the roadmap.
It's already in there.
Oh, it is?
Yeah.
Okay.
I think it's in Vagrant, so Packer would create the
Yeah.
BHD, and then with Vagrant
You
through
can
Hyper-V.
do that today. Yeah.
Oh, okay.
Yeah. You can reach out to me if you need help with that.
Okay.
Cool. Thank you.
Thank you.
All right, enjoy the lunch. Thank you very much, and don't forget to complete a form. Thanks for your interest in open source.